Ionic equilibrium, part 3. Ionic equilibrium 3.7 buffer system lesson outcomes. At the end of this lesson, students should be able to define buffer system and calculate pH and pOH for buffer solutions. Buffer solutions, a solution that resists a change in its pH when either concentration of hydroxide ion or concentration of hydrogen ion are added, made up of two solutes, either a weak acid and its conjugate pass as a soluble salt, such as acetic acid and sodium acetate, and hydrofluoric acid and sodium fluoride, or a weak base and its conjugate acid as a soluble salt. This is the ammonia and ammonium chloride, and this is the hydrazine and hydrazinium chloride. How a buffer works. Consider weak acid Ha and its conjugate base as A-. Must be able to neutralize both strong acid and strong base. Must have both weak acid and weak base and ion present in same solution in significant amounts. For example, if we add acid, it reacts with the conjugate base, thus preventing a build-up of hydrogen ion. If we add base, the hydroxide ion, it reacts with the conjugate acid, thus preventing a build-up of hydroxide ion. Calculating pH of a buffer solution. One common buffer is acetic acid or acetate ion buffer. In this case, reactions that occur are acetic acid neutralize added base. Look at this. This is the acetic acid and this is the hydroxide ion. And this is the acetate ion. Acetate ion neutralize added acid. Look at this. This is the acetate ion and react with the hydrogen ion to form the acetic acid. Acidic buffer solution. Consider an acidic buffer solution with an equal molar mixture of acetic acid and sodium acetate. So this is the sodium acetate and this is the acetic acid. Add acid. We look at this. The hydrogen ion react with the acetate ion from salt here and will produce the acetic acid. So when you add base, the hydroxide ion here react with the acetic acid to form acetate ion. Consider mixture of weak acid salt and weak acid. Look at this. This is the weak acid salt and this is the weak acid. So when you look at the Henderson Hasselbalch equation, so for the pH is equal to the pKa, you plus with the log, and for the conjugate pass, the concentration, you divide by the concentration of acid. Basic buffer solution. Consider a basic buffer solution with an equal molar mixture of ammonia and ammonium chloride. So this is the ammonium chloride and this is the ammonia. So the ammonium chloride will produce the ammonium ion and chloride ion. So for the ammonia, react with water, produce the ammonium ion and hydroxide ion. When 8 pairs, the hydroxide ion here react with ammonium ion from salt and produce the ammonia and water. When you add acid, the ammonia react with the hydrogen ion will form ammonium ion. So we look at the Henderson-Hasselbalch equation. So for POH is equal to the pKb you plus with the log for concentration of conjugate acid. Okay, this is the conjugate acid, ammonium ion, and divide by the ammonia, the weak pairs. Henderson-Hasselbalch equation for pH and POH. When we look at the pKa, so this is negative log Ka. So for pKb, negative log Kb. Exercise. A student has available 1 liter of the buffered solution, 0.55 molar acetic acid. So this is the Ka, and 0.45 molar sodium acetate. Determine the pH of this buffer solution. So the first step, you need to find the pKa, negative log Ka. So you got the 4.745 and use the formula of Henderson-Hasselbalch equation for pH. So pH is equal to the pKa you plus with the log concentration of salt divided by the concentration of weak acid, and you got the answer of 4.66. Try this tutorial.